Well, good morning, everyone, and welcome to our panel discussion. I have to say it's a little bit surreal to be here in beautiful Colorado Springs after being what seems like holed up for 18 months in my house. But so it's a pleasure to be here. As Davide said, my name is Trudy Kortes, and I am the Director of Technology Demonstrations at NASA headquarters. TDM, as I like to call it, is part of NASA's Space Technology Mission Directorate, and I'll be your moderator for the panel discussion today. So at NASA's Space Technology Mission Directorate, our main focus is supporting how technology drives exploration to the moon, Mars, and further out, which is absolutely convenient, because the theme of what we're going to be talking about today is technology drives exploration, paving the next era of space exploration. Our discussion today will focus on the importance of continued investments to mature space technology to enrich our nation through economic and societal impacts. And NASA, I would say by extrapolation, and then STMD more specifically, our mission is to drive innovation and advanced technology to ensure American leadership in a vibrant and dynamic and robust space economy. And what I might add is absolutely with relevance to the communities and the individuals who are outside of our aerospace community. I'd also just like to state that there's a lot happening in the world right now. Like I said, we're coming into about 18 months of this pandemic, and there are economic impacts of that, kind of the bounce back that we're seeing try to take place, but still with supply chain issues and labor shortages we're not immune to that, as well as the international turmoil we see happening today. Additionally, just a few months back, we saw the beginning foray into private space trips. So there's a lot of dynamics at play there. So with that, and setting that context for you all, we are going to jump into our panel discussion. Before I say that, we are going to reserve a block of time at the end for questions. And so operators are standing by to take your questions. There used to be a commercial about that, operators are standing by. But literally before this, they told me operators are ready to take questions and then send them up to us. So today we have with us 4 leaders in government, business, and academia. So we feel like we have all of our bases very well covered. So our outstanding group today will discuss the importance of investing in technology. And starting with, I would like to introduce first Dr. Bhavya Lal. Bhavya is NASA's Senior Advisor for Budget and Finance. Ms. Latonia Jones. Latonia is the Minority Serving Institution's STEM Research and Development Director. Ms. Lisa Callahan. Lisa is Lockheed Martin's Vice President and General Manager for Commercial Civil Space. And Dr. Janet Kavandi. She is the Executive Vice President of Sierra Space. So with that, we are going to jump right in. Bhavya, I'm going to ask you the first question. How do you see NASA's long-term role in boosting the overall space economy? And if you could address more specifically, how can NASA assist in growing the emerging cislunar economy?
Thanks, Trudy. First of all, thanks for the invitation. I'm delighted to be here, and thanks all of you for hanging on day 4 of the conference. So to Trudy's question, I see NASA's role fall into kind of 2 buckets. And this is my training as both an engineer and a policy analyst. So NASA plays an important role when there's likely to be a market failure. So for example, when technology development will take too long, or technology is too early stage, or it's too risky, as in we don't know if we are going to reach the outcomes we do. So these are the sorts of areas where the private industry is typically not as motivated. The second one is when benefits spill over to competitors, or what's called pre-competitive R&D, so core role for NASA there. A third area is, again, what's called industrial commons, database curation, test beds, facilities, areas where there isn't enough incentive or enough funding for the private industry to make an investment. So for example, again, to your question, Trudy, on the moon, so much of what we will do on the moon and what we are doing on the moon is an example of correcting these market failures, right? So whether it's ISRU or mobility or science on the far side, indeed, a study I did, and I hope you can find it online, we found that at least in the next decade or so, there's very little of commercial, very little on the moon that would be commercially viable, and NASA will have to, and the government, and the Department of Defense, and other parts of the government are likely to be core customers, both from the perspective of funding upfront R&D, but also from the back end, being customers. There's a second major bucket where NASA has a pretty key role, and this is sometimes that's often forgotten, and that's a systemic or system-wide thinking, where one individual player isn't motivated to think about the big picture. For example, coordinating within and outside government agencies, coordinating internationally, developing, for example, the vision for a lunar station. Another area where NASA has to play a really important role is maintaining international competitiveness. Again, an area where individual companies may not be as driven, but as a country, as government, it's important for us. Example being, we want to make sure we stay leaders in lunar exploration, whether it's landing on the moon or having permanent presence on the moon. And last but not least, NASA plays a critical role in disruptive innovation. Mainstream players, with all due respect to the mainstream players in the room, there isn't, as mainstream players typically will not invest in technologies that cannibalize their existing technologies. A really good example is the creation and development of CubeSats, right? This is not something that came from the big players. CubeSats were initially seen as toys, developed actually in a community college with NASA funding, and also initially promoted by startups. And of course, over time, they have become important. So those are some of the areas where NASA has played an important role. And it isn't just funding, it's also how NASA funds. So we can get into some of that as we talk some more.
Okay, thanks, Pavya, that was helpful. And I know for me in my program that resonated. We have quite a few partnerships and collaborators of all different sizes, including one that maybe people don't traditionally think of, but in some amounts we have academia also contributing, which leads me then to my first question for Latonia. So Latonia, academia is a critical component of NASA's technology research and development ecosystem, as well as a gateway to recruit and retain students in STEM. So as we look to the future of space technology, how do you see the role of academia changing or not to meet new challenges and demands faced by the agency?
Well, thank you, Trudy, for that question, and thank you for allowing me to be on this amazing panel. That is an amazing question because academia is the next generation of future leaders. And I think from an academic standpoint that the programs that we have, we can incorporate what the industry and the agencies have within the universities. We have non-traditional universities like the tech schools that apply that. But within traditional universities, we need to do a better job of making sure that the agencies and the industry technologies are on the cutting edge within the universities. Having more curriculums that feature things that's going on in the outside world, not just theory, but more of doing. And I think that having that will actually expand and enhance the diversity giving to the industry. We have internship programs, yes, that's wonderful, that's great. Everybody is not afforded the time to go and do an internship, but everybody goes to class. And so within academia, involving the leading and cutting technologies that's already out there within the educational institution would grow and help for a better student population as well as the business population after they graduate.
Very good. So some really practical applications too for students to know about in the classroom. Absolutely. Okay, so let's fold in Lisa Callahan to the discussion. So Lisa, I know for TDM, for my program, technology demonstrations, we've partnered with a few, which I touched on earlier with Pavya, non-traditional partners. One good example for us is our Mars Oxygen In Situ Resource Utilization Experiment, or what we call MOXIE, which is actually on the surface of Mars now. It just ran its 4th operating cycle to produce oxygen, and our first real adventure into the ISRU, In Situ Resource Utilization Technology area. That was proposed through a collaboration with Massachusetts Institute of Technology and the Jet Propulsion Lab. And similarly, earlier this year, Lockheed Martin announced a partnership with General Motors to develop a lunar terrain vehicle. And although GM played important roles in the Apollo era, it isn't a company most associated with space exploration. And I'll also add is that the daughter of a father who was a Ford Motor Company executive for his entire career, an engineering manager for his entire career, it always is close to my heart to know that there's synergies between the aerospace community and the aerospace industry and the automotive industry. So with that, do you envision Lockheed Martin using partnerships with what we would consider, you would consider non-traditional players more often? Or tell us your perspective on that.
Yeah, absolutely. So first of all, thank you again for having me here, and it's wonderful to be with all these ladies here on stage. As we look to the future of exploration and taking humans deeper into our solar system, we absolutely think it's going to take all of us coming together, not just the United States, multiple countries coming together, but also, as you mentioned, industries. And some of them may be non-traditional industries in the space domain. I think what we see in the current environment right now is that space is really exciting. There's a lot of new entrants into the space market. And at Lockheed Martin, we're embracing that. We're really looking to partner with some of those new entrants into the market space. A couple of examples of that is we're working with TIVAC on the SDA transport layer. We're partnering with ABL Space Systems in terms of their small launch capability and have partnered to buy up to 58 launches for that. And then your example that you used with General Motors, where we're really leveraging the investment of the auto industry in electrifying their fleet, the battery technology investment they're making, the automation technology that they're doing, and trying to bring that into the space domain. There's critical technologies and capabilities that are being developed here on Earth for things that we need to do that are going to be extremely relevant to what we need to do when we start to put humans further into space. So as I think about the future, I think there's a lot of companies out there that don't consider themselves space companies that are going to find themselves as a space company in one way or another. So if you're into mining or energy or construction, those are all industries that are going to be needed as we start to build up on the lunar surface or on Mars. Even if you're in the entertainment industry, when we send astronauts deep into space and to Mars and they're there for a few years, right, we need to have something to keep them occupied. So I think, as I said, there's going to be companies that don't even know they're in space and they will be in space. So yeah. I'm excited about it.
Interesting. Great points. And almost too, maybe us even changing our thinking about who we partner with to bring in some different entities that we normally wouldn't think about. Yep. So, Dr. Kavandi, Janet, if you would, talk a little bit about how public-private partnerships, which I keep mentioning my program, but it is big for my program. We have about 25% of the work that we do is with some key partnerships. That has spurred innovation within the space sector. So what do you think is needed to continue to broaden the space economy? And if you could provide any examples of areas of technology which Sierra Space might be targeting.
Thank you, Trudy, and it is a pleasure to be here with everyone. Yeah, I think if I didn't mention Dream Chaser, I'd be negligent. The evolution of lifting bodies from the, NASA Langley worked on them for years as the HL-20, and eventually Space Dev bought that capability, bought the IP, came into Space Dev, and then Sierra Nevada Corporation bought it, and so now it's Sierra Space. We've had lifting body designs for decades, but we've really never used them yet. And so we're finally enabling a lifting body to launch next year on the Vulcan rocket using the technologies. And again, we were talking about partnerships. Lisa's group helped build our Dream Chaser space plane, the composite structure part of it. So we are partners in many ways. And now we're finishing that design, and we'll be launching that next year. So that's one really key example, for my company of a transition from government to private sector to use in space and be used again by the government. Well, when we're thinking about commercialization of low Earth orbit, and we're taking all the expertise and experience that we've had in living on the space station for all these many years, all of the science that has been obtained from working on the space station, having worked payloads in a former life, and all the science, especially in the medical technology areas that we can transfer, that all of us are benefiting from here on the planet, and how we will continue to transform that knowledge into usable technologies here on the ground, remote medical services, even robotic operations are possible. Now we add, say 3D printing to the mix, and now we can maybe perhaps print organs in space that you couldn't possibly, print on the ground for microgravity reasons. So there's just a continuing evolution and discovery of all the things that we've done in space, primarily government-sponsored, that are now transitioning into the private sector. And we will continue to evolve that and bring some of those technologies home, and then discover more things in the future that we'll be able to put up there and explore even further into the universe. So really cool evolution.
It is. It's really a significant ecosystem.
Yeah.
And how that all translates, and especially like you said with terrestrial applications, what we can do. We like to talk about spin-offs, but terrestrial applications of some of the things that we've developed. And Lisa, a few minutes ago you mentioned the entertainment industry. I'll just say these lights are really bright. We could use Hollywood hair and makeup right now, I think, so because it must be, I don't know, like you can see every line. Anyway, okay, enough about that. Moving on, Pavya, back to you. So let me ask you, what do you see as the key tenets for this administration in terms of partnering with industry, academia, some small businesses, and how might that play out over the next few years, particularly as it relates to technology development?
Sure. So it was, in fact, under the Obama-Biden administration that NASA pursued commercial crew, and last year's successful launch of American astronauts from American soil on American rockets, by the way, that never gets old. I love saying that. Demonstrated that government can buy services previously considered inherently governmental from the private sector. More recently, NASA has used a commercial approach to land astronauts on the surface of the moon, and I remain optimistic of success in this domain as well. The administration expects to continue to explore creative mechanisms to affordably explore space and grow the space economy. Tech development and job creation, especially in underserved areas and at minority-serving institutions, is a priority of the Vice President and the administration. And the NASA's Space Technology Directorate, where you're at, Trudy, is really super well aligned with the administration's priorities. So STMD, for example, partners with industry through the tipping point, you mentioned that, and the announcement of collaborative opportunities ACO program, the tech demonstration missions program, the game-changing development GCD program, small spacecraft technology programs, all of them together really do focus on bringing in outside partners into NASA, much more so than many parts of the government. And with academia, we have the Space Technology Research Institutes program, the Space Technology Research Grants program, and of course the SBIR, STTR programs also focus on bringing outside entities into the fold. And across these programs, we cover the waterfront of technologies that are critical to jumpstart what I hope we get a chance to talk about, the space industrial revolution. These are technologies like on-orbit servicing, assembly, manufacturing, space nuclear propulsion and power, unique approaches to launches. Across the board, we are investing in the future of space, and I don't see why this trend will slow down. Two particular approaches that I think NASA has experimented with successfully. I started with some of those, and we hope to continue to work on those. Overall, sort of there's a place for cost-plus programs, obviously, but going forward, when NASA wants a hole dug, instead of specifying, use this drill bit and this kind of technology, NASA just would say, this is the dimension of the hole we need. and let industry and startups and international partners propose solutions which tend to be innovative and cost-effective. Another mechanism that we want to be looking more are advanced purchase commitments. So these are sorts of mechanisms that are pretty common in other sectors, vaccines. Governments often look at rare diseases and vaccines and say, hey, if you produce this, we will buy it. NASA should be looking at some of these approaches. For example, on the moon, we could be, instead of developing power solutions, maybe we should be just purchasing power, right? We would say, we will pay X dollars per kilowatt hour for power or water or regolith or propellant. And it's hard, the economics is hard, it's legally hard, but those are the sorts of things we want to be doing as we move forward.
Okay, thank you. So you mentioned MSIs. Latonia, from your experience, what are the biggest challenges that MSIs, such as historically Black colleges and universities, face when competing for NASA or maybe even other organizations' opportunities? And what are some actions that the agency could take in the near term to address those challenges?
That is a really great question. The biggest challenge is, I think, that the knowledge of knowing the capabilities for the MSIs. For instance, we mentioned 3D printing. We have a university that's within our consortium. We are the only consortium that has a conglomeration of 70 MSIs where you can come into our consortium. It's rapid acquisition. It's not the tedious process of going through the normal acquisition process. But she mentioned 3D printing. We have a university that actually has had all phases of the STTR, phase 1, phase 2, and phase 3, because they are developing a functionally electronic to be able, if you're in space and let's say something breaks down, how can you get to what it is that you need? So this 3D printer is actually supposed to be able to develop that product. Something breaks down, I need a tool, you use this 3D printer. So I think knowledge of knowing what these MSIs have to offer is probably the biggest challenge. We talk oftentimes about thinking outside of the box, but a lot of times we have to get out of the box in order to think outside of the box. And so going to the normal institutions time and time and time again is easy, but that's not innovative. If you don't understand what's out there, you don't understand what the MSIs have to offer, then you cannot diversify your portfolio. As I said, a lot of universities we have within our consortium, the agencies can come directly through our consortium through this vehicle in order to get to the MSIs. If there's no knowledge of their capabilities, then you can't get to them. That is by far the biggest challenge. So I think what needs to be done and what can be done is, the agencies need to get out more, understand who's out there. Look at the research capabilities for the MSIs. There are 835 MSIs. There are 102 HBCUs. I don't think anyone knows about our consortium. I also don't think anyone knows that there is a White House initiative for HBCUs that executive order was issued in 1980. No one knows about that executive order. That executive order is to promote historically Black colleges and universities to have these opportunities, to afford them the opportunities to be able to compete with other industries. So I think, again, the knowledge, knowing the capabilities of the MSIs is probably the biggest challenge.
Yeah. Thank you for that. So really educating ourselves on what's out there, like you said.
Absolutely.
Yeah, okay. So communication and education is key to that. So Lisa, similarly, I asked Janet about technologies for Sierra Space. So what new technologies does Lockheed Martin have on the horizon that you believe are key to taking space exploration to the next level or really needed to sustain exploration?
Yeah, thanks. Trudy, you mentioned earlier COVID, and that we've all been through that and in lockdown, and I think every one of us here has faced the need to really use digital tools and a virtual environment in which we could collaborate and keep moving forward to meet our mission needs and things during COVID. And so one of the areas that Lockheed Martin's investing heavily in is in digital thread, being able to use digital technologies to integrate from proposal to design to manufacturing to actually operations, and leveraging the same tools and the same, I'll say, digital design or digital twin throughout that whole process. And so that's a technology that I think industry-wide is doing, but COVID really enabled us to, was a forcing function to really accelerate a lot of that. So I think we're in a much better place. It's the silver lining, one of the silver linings, I think, in my view of COVID, which has obviously been a horrific pandemic and disease, but I always like to try to find something positive to come out of that. And so, we're looking at how can we build that digital twin, and on programs like Orion, having that digital twin, being able to use it into the manufacturing process, where we can use augmented reality and actually see where clip-ons or equipment needs to get put onto an Orion spacecraft, where the technicians just simply put on AR goggles and they can look at the vehicle and they can see the instructions that they have for where those clip-ons go. It's saving us, on the order of 90% in our labor, which is just amazing. And so for the exploration that we want to do, cost savings and affordability are a huge driver to that. But if you take that even farther and you look at the operational uses of that, as we go deeper and deeper into space, particularly if we start to send humans to Mars, they're not going to be able to rely on the ground if they have an issue. And so if we have that digital representation of the vehicle that they're flying in, they can actually use technology like digital assistants to ask questions of their spacecraft to try to debug things and get answers back. Or they could leverage 3D printing to be able to print spare parts and not have to carry all that with them in their transportation. So this whole digital thread, I think, has huge implications going forward. From a capabilities perspective, we're very focused on space nuclear, whether that be nuclear power or nuclear propulsion. We think that just provides great input, particularly as we go further and further into space, and we need to sustain ourselves on the lunar surface for longer periods of time. Habitation is going to play a role when we bring astronauts and civilians into space, and they need to be able to survive in those environments. And then mobility, as we've already talked about from the partnership we have with General Motors. Once astronauts get to the surface, they're going to need to travel places to do science and things, and we think mobility will be critically important, whether it's with humans or robotically.
Very good. So hold that thought on nuclear power and propulsion. I think we're going to be able to get back to that in a few minutes. But the agency has a concerted effort now too in digital transformation. Yep. And I was just talking to someone here this morning about digital engineering. So, so interesting to hear all of that with some future work to be done. So Janet, back to you. You have many years of experience in both NASA and industry, and I'll just note that Janet recently received the Lifetime Achievement Award from the Women in Aerospace organization. So congratulations on that. I just happened to be on their emailing list, and I saw that come through yesterday, and I thought I might surprise her and mention that. I hope that didn't embarrass you too much, but congratulations on that. So with that experience, Janet, what, if anything, do you wish you had known about partnering with industry when you were one of the leaders at NASA?
Yeah, that's a good question. One of the first things I would recommend if you go from NASA to industry, I know NASA's the king or queen of acronyms, but there's one acronym I did not know, which was EBITDA. So if I embarrassed myself terribly whenever I went into industry and didn't know that acronym, so that would be one area of advice. Actually learning how finances and businesses work on the financial side is very helpful because NASA, of course, doesn't have to make a profit, as other government agencies don't have to do that. But it's very important in the private industry. So, learning about margins and rates and all the kinds of things when you're doing proposals and how you can be competitive yet not so competitive that you lose money. Those kinds of things that we don't I didn't get to do as an employee in the government. There is, I think, or was an assumption on my part and maybe some other people's part that it might be faster, better, cheaper in industry. Sometimes it is and sometimes it's not. I mean, it's still challenging. Space is still hard. Yep. No matter who's building whatever rocket or spacecraft or components that there are. So assuming that it'll be easier for industry to do things isn't always the case. So I think the challenges are still there. We still have to work through those, and we still need to make sure that we have all the right skill sets and quality assurance to make, and SNMA to make sure that everything gets built to the quality level that NASA has always demanded, and having that experience in the agency really helps me in private industry to make sure we're building a quality product. So those are a couple of the business aspects. I guess the other thing is that at NASA, you can pretty well rest assured that your workforce is going to be with you for most of their careers. Most people will, who start at NASA, retire at NASA. They may go out and do something different, like I did at the end of their career, but you can count on having your workforce, a pretty steady workforce. And in industry, especially lately, I think you can't count on a steady workforce. People will switch jobs frequently, and what you have to pay to retain people is significant. So it's hard to compete in that area, especially in this area where we're in an area where you have a lot of aerospace companies all seeking out the same talent. So probably doing a better job of recruiting and making sure we have inclusivity and diversity in our workforce, and improving in that area, I think, is something I want to really focus on in this job, and to try to attract early career people and retain them longer. And we've learned another silver lining, I think, from COVID is that we can be more flexible. If we have the digital tools, we can allow people to work remotely more often than we could in the past, and we get very good quality work from people. They actually, a lot of people work more when they're working remotely than they do in the office because there's fewer distractions and they save all the travel time. So adjusting to that paradigm as well is probably something NASA's doing as well, but something that at least I've experienced in the last couple of years and learned to adapt to, and trying to adjust to that more as well.
Yeah, the competition for labor right now is pretty incredible, what we're seeing pretty much across the board. And we heard that Space is Hard theme opening day here a couple of times, and it really is. And it's not just the difficulty of the technologies we're developing, but if you think about the integration piece, well, we've all talked about how this is an ecosystem and there are a lot of players, and just the communication and the education of each other. I mean, that all ties together. To me, that's one of also the hard parts about space, is just that element of being able to bring it all together. Sometimes you watch a launch and I think it's amazing that got off the ground with just everything that had to go into it. Okay, so just a reminder, if you do have questions, text them in. I believe a phone number was provided to you all to do that. So now is the, thank you, it's right behind me. Okay, it's right behind, thank you, Bhavya. It's right behind me. So now is the time to text in your questions if you have any. But if I could pivot for just a minute to something that's a little bit more specific. Space, nuclear power, and propulsion are both very important for exploration beyond LEO, and both NASA and Department of Defense are working to advance these technologies. So I'd like to ask what people on the panel, anyone can jump in. I think I might start with Bhavya, but what are your thoughts about the challenges facing those technology areas, nuclear power and propulsion, both technically and in terms of public perception and politics? So Bhavya, let's start with you if we could.
Sure. So I was on a National Academies committee that looked at nuclear propulsion, in particular sort of figuring out the trade-offs between nuclear thermal and nuclear electric propulsion. And actually it is a hard problem. The bottom line of the Academies committee report was that there hasn't been enough investment in NEP, nuclear electric propulsion in particular, to be able to do a down select. So one of the big challenges we need to overcome is get enough information that the down select can happen. And of course, the other major challenges, in addition to some of the technology challenges, is funding. NASA would like to have a human mission going to Mars by 2039, and the committee ascertained that with NTP, nuclear thermal propulsion, with aggressive funding, that would be feasible. However, if we went the NEP chemical route, that is like 2039 is likely not an attainable date. So a lot of thinking that needs to be done. And when you're making these trade-offs, it isn't just about the core technology issues that are unique to each technology. So for NTP, for example, you need very high temperatures, so materials and reactor properties that can respond to that. But there's also broader concerns that we need to think through. For example, one advantage nuclear offers over chemical is a higher specific impulse, which essentially translates into a less need for less propellant. And as you know, less propellant means fewer launches, and fewer launches means lower cost. But the question is the need for less propellant, aka fewer launches, important if we are trying to grow the space economy? So the need for more launches may bring more commercial and international partners in the game. So maybe that's a good thing, which maybe favors NTP. But what happens also if the cost of launch plummets, and what happens if we can have propellant depots in space? And the number of launches becomes a less relevant figure of merit. Again, how do we do trades differently if those sorts of things happen? My point is that we need to be strategic about how to use the mission pull from Mars to expand the space economy. For example, which propulsion system could provide a rationale for ISRU on the moon? Because one of the problems we have with ISRU, apart from a tech push, which is full of challenges, but there's also not a strong mission pull. So could Mars provide that? So these are some of the questions to ask. There's, Trudy, you mentioned it isn't just technology challenges. There's legal regulatory challenges as well. Luckily, in 2019, there was a presidential memorandum that laid out the process for how you might approve the launch of a space nuclear fission system, which up until then wasn't really laid out in more detail. And last, I guess, I would want to say that the challenges are policy and politics. Von Braun said we can lick gravity, but sometimes the paperwork is overwhelming. So I think this is a challenge we will face as we develop space nuclear. Having said that, it is a challenge worth addressing because, as Trudy said, we cannot explore the solar system without space nuclear power and propulsion.
Very good. Anyone else want to jump in on the nuclear?
I'll just add, because I would never argue with Bhavya on nuclear.
Never.
But I would just add the other challenge that we see is the cryofluid management and storage piece of that. And we're really excited to be partnered with STMD on the tipping point to do a cryofluid management demonstration here in space in the future. And I think that will help us with some of that technology advancement as well.
Yeah.
That is absolutely a core challenge for NTP.
Yes.
And to some extent, NEP as well, yeah.
And I'll just add, cryogenic fluid management is making a roaring comeback in my program. It's quite a healthy portfolio that we have now. 4 public-private partnerships that we announced last year and are either awarded or in the process of getting awarded. Like you said, Lisa, one with Lockheed Martin. So that technology area has been a long time coming. If you talk to the technologists in the area and the community, since the 60s, we've needed some on-orbit demonstrations. So we're looking forward to those in the next coming years with our partners, and then a lot of in-house we have going on at the agency. So if there are no questions from the audience, I'm not seeing any necessarily. Then I think thank you, by the way, all of you, for being here today. I've learned so much from you, and I've worked in this area for a long time, so it was fascinating for me to hear everything you had to say, your perspectives. But I would like to call on each of you, if you wouldn't mind making a few closing remarks. It can be a word, it can be a sentence, it can be a few comments that you have about this area, collaboration, all the things we've talked about this morning. But I think I'm going to reverse order then. I'm going to start with Janet on the end, if that's okay with you.
All right, well, thanks, Trudy. No, I stayed in the space business. I spent 25 years at NASA. I loved every minute of it. I had the wonderful opportunity to fly in space myself and to experience what it's like to be there. And I would really love to share that opportunity as much as possible with as many people as I can. So I chose a company that I respect greatly, and I really, really would love to be able to fly a space plane again. I'm not a closet, I'm a shuttle hugger. I loved the space shuttle, and I loved everything that it could do. So I'm hoping to be able to bring another space plane back to our runway and enable crew and cargo on that vehicle in the future, as well as provide a destination at some point. If you look at our display, you'll see a life habitat, which is a an inflatable module that's 3 stories tall. So we think that we can always continually improve on our ability to provide destinations in low Earth orbit, to provide continuing technologies, opportunities in space, to provide international cooperation in space, provide diversity and inclusion in space, and to just continue to develop space into the economy that I believe is destined to happen. So appreciate being here. Thanks very much for your attention today.
Okay, very good. Thanks, Janet. Okay, Lisa, if you could.
So I would just say this is an incredibly incredible time to be in space. I mean, if you just walk the exhibit floor or listen to the discussions that have been taking place here this week, there is no better place to be in my mind right now than to being in the space domain. And I'll just emphasize again, I think it's going to take all of us to get to that space exploration that we want to, the economy that we're looking for in space. I have enjoyed the partnerships that we've had with different industry partners, with academia, with the government, and with international partners. I think it's not an or, it's an and. It's all of us coming together and inspiring the world. And I just think we're at a time across the world right now with all that we've been through over the last 18 months and more, and the impact that COVID and others has had on people's lives, that space is here to be inspirational. And I think we should leverage that to inspire the world and bring us together as one.
Okay, very good, thank you. And Latonia.
Great, so I think this is a great time. As she said, today is Katherine Johnson's birthday. She's born August 26th, and if anyone doesn't know her, she's a brilliant African-American mathematician. You probably know her from Hidden Figures. And so I think it's an amazing time to bring academia, especially historically black colleges and universities. She graduated from West Virginia University, which is a historically black college. I don't want to wait until there's a movie about, a black female mathematician or a black female astronaut. Now is the time to kind of, rise up and understand that, diversity is here. It's always been here. Just making sure that that the knowledge base is there, and looking forward to the future. I'm very hopeful for what's to come.
And leveraging that. Very good. Okay, and Bhavya, we'll finish with you.
So it's nearly the end of the conference, and I want to leave you all with some food for thought. So, the last 200 years have seen a series of industrial revolutions that have transformed modern society. So the first one, well, the steam engine brought on the first industrial revolution. The age of science and mass production marked the second, and the rise of digital technology began a third one, which of course continues through today with AI and computing and data. But throughout this time, however, we have remained Earth-centric, limited by our ability to lift resources, the size of the rocket fairing, right? Going forward, as the cost of accessing space falls, as we develop capabilities to service, assemble, and manufacture in space, as we grow our ability to provide more power and propulsion in space, I believe we are poised to expand the boundaries of what is considered our realm, and with it, access to nearly infinite capabilities and resources of space. This is what I'm calling the space industrial revolution, and it implies that we switch from this Earth-centric paradigm to one that, as Jack Marburger, who was President Bush's science advisor, said, bring the solar system into our economic realm. The paradigm shift, I've heard it called at this conference, a space superhighway. I've heard it called space infrastructure, space logistics, would allow, and again, putting on my NASA hat, would allow our space systems to live longer and journey farther, and make both robotic and human spaceflight more sustainable, more affordable, and more resilient, which returns me full circle to the topic of this panel. This is how technology drives exploration, and I cannot wait for us all to be part of this new industrial revolution.
Very good. Okay, thank you. So I'll just close with a few things. First of all, all of these wonderful individuals, the panel here today, their bios are online. We did not read through them today in the essence of time, but if you'd like to go read more, as well as our organizations, you can look up that information as well. Regrettably, some questions did come in, but the inbox was not set to the right, it wasn't set to the right inbox, so I didn't get them. However, we have a few minutes left, and there are some specifics for individuals. If you'd like to come up after we finish and have conversations or out in the lobby, I think would be happy to do that if anyone's interested in that. So thank you, everyone. I'll just reiterate what Bhavya just said. Technology drives exploration. That is our Space Technology Mission Directorate tagline. We say it, and we say it often, but that's because we believe it. It's very important that we keep doing this for several of the great reasons we mentioned today, but just too, there's a lot of relevance here in a more than $900 billion space economy. So thank you for attendance today. We hope you enjoyed this session. And like I said, if you'd like to speak to any of the panelists or myself out in the lobby, we'd be happy to do so. Thank you.
Thank you.